Let's look at the parent function of a rational function. Rational function is like this, 1 over x. Okay? This will be the first time that you see an x variable in a denominator. We have fractions with polynomials now. They're called rational functions. What this looks like, I sketch this for you, and we can see it on the calculator too. If I were to graph 1 over x and my y equals, you can see how in quadrant 1 and 3 we have just kind of these little curves. Okay, so what's happening is it starts really close to the y-axis, comes down, and then gets really, really close to the x-axis. And then here it starts really close to the x-axis, comes down, and then gets really close to the y-axis. It'll never cross the x-axis or the y-axis because those are called our asymptotes. We studied those a little bit last chapter, but they're going to be a little bit more relevant to us on this chapter. Since it gets close to the y-axis here, close to the x-axis here, we have this would of course be called our vertical asymptote, and this one here is called our horizontal asymptote. Okay. Our vertical asymptote we can abbreviate it VA for vertical asymptote. Our vertical asymptote here is at x equals 0. Okay, so our graph will not cross that line at x equals 0. Our horizontal asymptote and we can abbreviate it HA, is at y equals 0. Because y equals 0 is this line, and my graph will never touch that. Okay? So that's kind of what the parent function looks like there. Vertical, horizontal asymptotes. Okay? Now, we can also throw in with this, is we can throw in some transformations. If I add and subtract to the whole function on the outside here, that's going to be up or down. If I add or subtract just to the x, that means I'm adding subtracting in the denominator. That's going to be my left and right. Okay? So if it's in the denominator, adding subtracting, that's left and right. If it's outside the fraction, that's up and down. Okay? Of course, if I multiply by a number, that's vertical stretch and compression. And of course, negatives always mean reflect over the x-axis. Okay. So once my parent function here, 1 over x, moves up and down, left or right, my asymptotes, of course, are going to move. Okay, so let's just look at the vertical asymptote. My vertical asymptote is right here, right? It's vertical, my vertical asymptote. Okay, if I move up and down, see how I'm still on the y-axis? So if I move up and down, my vertical asymptote stays x equals 0. But if I look at the horizontal asymptote, and I move up and down, see how my horizontal asymptote is moving with it? Okay, so we can make that note that, so it's going to it changes, vertical asymptote changes when I move left and right. And my horizontal asymptote here changes when I move up and down. Okay? So that's what you kind of have to remember or memorize, right? Is you need to know that vertical asymptote, if you think vertical line, the only way it changes is left and right. If you think horizontal asymptote, horizontal line changes up and down. Okay. The last thing we can talk about then is domain and range. Let's look at our domain first. Our domain is all of our x values, right? All of our x values. So if you look at my graph, I go left and right forever. But as I'm coming in, what happens when I get to the y-axis? It splits off, and I can't touch the y-axis. So my domain is all x values except 0, because that's where an asymptote is. So your domain is always opposite of your vertical asymptote. Because if I have an asymptote at 0, then I can say my domain, x cannot be 0, because I have an asymptote there. Same thing with horizontal. If I look at horizontal, my range, right? My range is my y values. I'm coming all y values, all y values, all y values, and as soon as I get close to my asymptote, it splits off and it can't be 0, because it'll never touch that line. So I can say for here, for my range, if my asymptote is 0, y can't be 0. They will always be opposite. Whatever my vertical asymptote is, my domain cannot be that. Whatever my horizontal asymptote is, my range cannot be that. Okay, so if you look at the first example, again, 1 over x is my parent function, and then I'm subtracting 3. So the first thing we're going to do is identify any transformations. What transformations do I have in this one? I just moved down 3. Very good. Okay, so now I want to think for my asymptotes, I have a vertical asymptote and horizontal asymptote, right? And x equals y equals. So if I have a vertical asymptote, think vertical line. Vertical line is this way. Vertical lines only change if I move left and right. Did I move left and right? No. So my vertical asymptote stays 0. And then think horizontal asymptote. That's a horizontal line. And horizontal lines will only change if I shift up and down. Did I shift up or down? Yes, I moved down 3, so my horizontal asymptote should be a -3 if I moved down 3. And then from there, I can look at domain and range. Domain is my x values. So if I have an asymptote at x equals 0, that means my domain, x cannot be 0. And for my range, if I have a horizontal asymptote at y equals -3, then my range, y cannot be -3. Those will always be opposite of each other. Vertical to domain, horizontal to range. So to graph this, the best thing to do first is sketch in your asymptotes. So I would sketch in x equals 0, y equals -3. We kind of have an idea. I'm going to have a C curve here in quadrant 3 and a C curve here in quadrant 1. Okay, but let's find some points to graph. If I pull out my handy dandy graphing calculator, when you do graph this, you're going to have 1 divided by x in parentheses and then subtract 3. To say you want only the fraction to be 1 over x. And then graph. And what your graph will show you is, yep, you can kind of see how it just moved down 3. Go second graph. Here's your horizontal asymptote at x equals 0, or it'd be vertical asymptote at x equals 0. So what are some good points here? I don't know. And you don't have to have the same points as me. So there's some points, and go on the other side of the vertical asymptote. 1, -2, and 5, -2.8. There's some points. And then you graph those. Here's my first, and again, remember you're just going to get really close to the asymptotes but not touch them. So that kind of helps you graph it. So it looks like that. Okay, so move to this example here. What are my transformations? Up 5, and what else? Right 2, very good. Up 5 and right 2. Okay, so now let's think of our vertical and horizontal asymptotes. My vertical asymptote is x equals 0 unless I move left and right. So did I move left and right? Yes. So my vertical asymptote is 2. Very good. Horizontal asymptotes are 0 unless I move up and down. Did I move up and down? Yep, I moved up 5. And I can sketch those in. Vertical at 2. Vertical line. Horizontal at 5. Okay. And then to finish, domain and range. Domain is my x values, but if I have an asymptote at x equals 2, my domain cannot be 2. And my range is the y values, but if I have an asymptote at y equals 5, my range y cannot be 5. You cannot have values where your asymptotes are. So then my last step, again, would just be to graph. And I can have my calculator help me with that. One thing I want you to notice when you graph this, you do need double parentheses when you have a transformation in the denominator. So it's going to look like this. Parenthesis 1 divided by parenthesis x minus 2. Close your parenthesis. Close the parenthesis for the whole fraction. And then add 5. Because you want to say 1 divided by that subtraction, and then you want the parentheses to say you're only dividing that. And then when you graph it, what happens, your calculator actually puts in the vertical asymptote for you. You didn't see that on the one before because it was on the y-axis. But this right here, it actually kind of sketches in all vertical asymptotes, because sometimes you can have more than one. So then I can go second graph, find some, again, there's my vertical asymptote at x equals 2. Let's see, what would be some good ones? -3, 4.8, 1, 4, 3, 6, and maybe one more. If you just get 2 points on each side of your error, your vertical asymptote, that's probably good. 9 and 5.1. So let's see, 1, 2, 3, 1, 2, 3, 4.8. It should be -1, 4, right? Oh, 1, 4. Oh, yeah. So there's one side and then 1, 2, 3, 1, 2, 3, 4, 5, 6, 9, 1, 2, 3, 4, 5.1. And again, you have those 2 curves. Let's do this final example right here, if you find this one in your notes. But I want to change one thing about it. Let's make this a -2, just so I can show you what that looks like. Okay, add a reflection to it. Okay. All right, so what are my transformations? Down 1, good.
Left 6.
Down 1, left 6, good. And these is 2 things right here. Negatives always mean reflect over the x. And the 2 is going to mean vertical stretch of 2. Yep. Whenever you have a number there besides 1, it got multiplied by something, meaning there's a vertical stretch or compression. Okay, so vertical stretch of 2. Okay, so now I can look at vertical and horizontal asymptotes. Vertical asymptote is x equals 0 unless I move left and right. In this case, I moved left 6. So my vertical asymptote would be -6. And some kids get confused because this is a +6 here, but your asymptote is going to be a -6 because this means left, and that's a negative. It's going to be opposite. It's a little bit confusing. Horizontal asymptote changes when I move up and down. So since I moved down 1, it's going to be -1. So I can sketch those in. 1, 2, 3, 4, 5, 6. And -1. And then, of course, my domain, if I have an asymptote at -6, x cannot be -6. And for range, if I have an asymptote at -1, y cannot be -1. And then I can find some points. Now, instead of quadrants 1 and 3, since it got reflected, it is going to be 2 and 4. Right? They're going to be opposite, and you can see that when you graph it. Parenthesis, -2 divided by parenthesis, x plus 6, close the parenthesis to the fraction, -1. Okay, make sure the fraction's in parentheses and make sure the denominator's in parentheses. Graph, see how I'm here on these two? It got flipped, okay? So that'll happen. And again, there's my vertical asymptote. It sketched it in there for me. So second graph, I'm going to have some negative x values. So I can do, let's see, -10, -0.5, -7.1. That'd be good for that side. And then -5, -3, 0, -1.3. So it's a little bit backwards.